It was supposed to stay hidden, buried beneath layers of secrecy, deniability, and fear. But one misstep, one misunderstanding, and the world came closer to nuclear war than anyone ever realized. In the tense silence of the Cold War, the United States and the Soviet Union stood locked in a standoff that never truly slept. Every radar signal mattered, every military movement was watched, and every decision carried the weight of millions of lives. By the late 1950s, a single question haunted military planners. What if the enemy struck first, without warning? No sirens, no time to react, just a sudden flash and the end. The answer had to come before the attack ever did. So deep inside classified rooms, far from public view, a bold idea began to take shape. A system so advanced, it could see danger before it arrived. A shield built not from steel, but from information. High above the Arctic, across frozen, desolate landscapes, a chain of radar stations stretched into the unknown, watching, listening, waiting. But there was a problem. Radar wasn't perfect. Signals bent, echoes lied, blind spots lingered. And in a nuclear age, even a few minutes of uncertainty could mean the difference between survival and annihilation. So planners began to think bigger, much bigger. What if the answer wasn't on Earth at all? What if it was in space? It sounded impossible, like something pulled straight from science fiction. But during the Cold War, science fiction had a way of becoming real, faster than anyone expected. The idea was simple, at least on paper. Push technology higher, expand detection beyond the limits of the ground, use the upper atmosphere, maybe even space itself, to gain an advantage no enemy could match. But there was one problem. No one fully understood what would happen if nuclear weapons were used that high above the Earth. So there was only one way to find out: test it, quietly, secretly, and far from the public eye. Preparations began. These weren't ordinary nuclear tests. There would be no desert blast zones, no towering mushroom clouds over empty land. These detonations would happen high above the planet, in near space, where the rules were different and the consequences were unknown. Even inside the government, few truly grasped the risks. Then came the moment that changed everything. 1962, at the height of global tension, a nuclear device was launched high above the Pacific Ocean, rising higher and higher until it reached the edge of space itself, and then detonation. For a brief moment, the night sky transformed. A wave of light spread across the horizon. Colors shimmered in strange, unnatural patterns. Greens, blues, purples, dancing across the sky like something almost beautiful. It looked like a miracle. But it was something far more dangerous, because what followed, no one had expected.
An intense burst of electromagnetic energy exploded outward, racing through the atmosphere at unimaginable speed. It collided with the Earth's magnetic field, triggering effects scientists had only theorized about. Within seconds, systems began to fail. Hundreds of miles away, streetlights flickered, then died. Communication networks broke down. Power systems glitched without warning. And in orbit, satellites, some of the most advanced technology ever built, started to malfunction, one by one. The world didn't see it coming, but the impact was real, and it was spreading. What was meant to be a controlled experiment had just revealed something terrifying. A single high-altitude nuclear explosion could cripple electronics across vast distances, invisible, silent, and devastating. The implications hit fast. If this could happen during a test, what would happen during a war? The answer was chilling. A conflict wouldn't begin with explosions on the ground. It could start with an unseen pulse, knocking out communications, blinding early warning systems, and throwing entire nations into confusion. And in that confusion, decisions would have to be made, fast, with incomplete information, with fear driving every move. During the Cold War, that kind of uncertainty was deadly, because uncertainty leads to assumptions, and assumptions can lead to retaliation. At the same time, the Soviet Union was running its own experiments. Different locations, different conditions, but similar results. Both sides were discovering the same thing. They were playing with forces they didn't fully understand. Back in Washington, concern began to rise. Military leaders realized something unsettling. If the United States could disrupt its own systems by accident, then in a real crisis, the same chaos could unfold without warning. Imagine it. Alarms sounding, radar screens flickering, communication lines going silent. No clear enemy in sight, just failure after failure, stacking up in real time. Would it be seen as a glitch or the first strike of a nuclear attack? That question alone was enough to push the world closer to the edge. And then another problem emerged. The explosions weren't just creating pulses, they were leaving something behind. Artificial radiation belts, trapped within Earth's magnetic field, invisible, persistent, and dangerous. Satellites passing through them began to degrade. Systems failed faster than expected. Space itself was becoming a hostile environment. This wasn't just a military concern anymore, it was global. But stopping wasn't easy. The Cold War didn't reward hesitation. Every advantage mattered. Every breakthrough carried weight. If one side stopped, the other might surge ahead. So for a time, the tests continued. But behind closed doors, something was changing. Scientists, those who had once supported the program, began raising alarms. The data they were collecting wasn't just groundbreaking.